Good morning. This is Jim Haldeman, Business Development Manager for Instrumentation at the Lesman Instrument Company. Thank you for joining our webinar this morning, where we'll be discussing inline process refractometers, how they're used, and may improve your quality and reduce costs. Our presenter this morning is Michael Kohlmann. Michael is the Regional Sales Manager for Vaisala Liquid Measurements. Vaisala Liquid Measurements purchased K-Patents several years ago and is now completely known as Vaisala. Michael has more than 20 years of experience with supporting a variety of instruments within the process and the water and wastewater industries. At Vaisala, Michael is Regional Sales Manager in the Midwest. Michael focuses on fluid flow control in industrial process, water, and wastewater applications. With that being said, regarding questions in the presentation, if you look at the drop-down menu in the toolbar, there is a tab for questions. Please enter your questions within the tab. I will monitor the questions being asked, and I will ask them to Michael at the appropriate time. This webinar is being recorded for future use. And with that, I'm going to turn the audio over to Michael to begin his presentation. Thank you, Michael.
Hey, good morning. Thank you, Jim. And thanks everyone for joining. Appreciate it. This morning, we're going to go over, as Jim mentioned, refractometer measuring principle and how you're going to use them, why you're going to use them, what they can and perhaps can't do. We'll talk a little bit about Vaisala. There's different ways to pronounce the name of the company, even within our company. I call it Vaisala. We are a Nordic-based company out of Helsinki, Finland. We're a measurement company primarily with two distinct business units, a weather and environmental group, and then the industrial measurements group. The weather and environmental side produces products used in meteorology, aviation, ground transportation, renewable energy. A lot of these products measure and even help predict weather-related events such as storms, lightning strikes, hurricanes, and even road conditions. Some of the industrial products include high-end humidity, temperature, carbon dioxide measurements to help monitor and control indoor air quality, for instance. Those devices are used in many critical applications where it's vital to monitor. We're a few slides ahead, sorry about that. So they monitor and protect things like vaccines by ensuring that they stay at the right temperature, or help protect precious items in libraries, museums. In fact, we even play a role in protecting the Mona Lisa. Here you can see a couple of our industries. And we even measure the barometric pressure and humidity in inhospitable locations like Mars, on the Mars rover. So yes, we are actually in on two different planets. So the liquids group, we measure, primarily we have our refractometer, and some of you may not even know what a refractometer is. That's where we'll get into it in this presentation, an overview of the Vaisala Polaris refractometer for reliable, stable measurement of liquids, and actually more appropriately, the dissolved solids in a liquid. So here is an overview of our Polaris applications. We have applications in food and beverage here in the Midwest. It's primarily food and beverage for me. We do pharmaceuticals, chemical companies, pulp and paper. Pulp and paper is huge for us as well. We do a lot of different chemicals within pulp and paper and measure the dissolved lignin and other things in the chemicals, the aggressive chemicals that are in pulp and paper. Sugar and sweeteners are one of our mainstays as well. We even measure de-icing fluids to keep air travel safe. So some of the glycols that are used in de-icing. So the Polaris refractometer, inline refractometer, provides a temperature compensated concentration output. It's an analog 4 to 20 or even a digital communication output, Modbus TCP IP over Ethernet, directly from the refractometer sensor, or from what you see on the screen here is a refractometer and a transmitter that it's connected to. It's sort of the interface, the HMI, and so on. We'll talk about that in a little bit. That output can go directly from either the sensor or from the transmitter into the PLC and help you control what your process conditions are at, whether it's the concentration, as I mentioned, sugar, or an acid concentration, whether you're increasing the concentration or reducing the concentration. We can help you get there very accurately, sometimes to within 0.1% of whatever it is that you're looking for that's dissolved in that solution. So many of you may know what a refractometer is and how it works, but there are going to be many on this webinar that would like to know what it does, why it's different than perhaps a Coriolis or a conductivity sensor. So what is refractometer? What is it? How does it work? So a refractometer is an optical device that measures the refraction of light in liquid caused by solids that are dissolved in that liquid. This is known as the TDS, or total dissolved solids. It's really that simple. In this example, I'm showing a pencil in a solution. And if you look down at the pencil, it seems that it bends on the surface of the solution. The bending angle depends on how much is dissolved in the solution that you're measuring, or the concentration of that solution. The apparent bending, and I call it apparent bending because it's really not bending, the apparent bending is larger in stronger solutions than in weaker solutions. We take advantage of this. This is known as Snell's law. It can, for instance, measure how much sugar is in a beverage. And in fact, one of the scales for a refractometer is Brix. And basically that's a percentage of sugar in water. One Brix, the definition of one Brix is 1 gram of table sugar dissolved in a 100 gram solution of water. 10 Brix is 10 in 100, so you would have 10 grams of sugar and 90 grams of water. Sets up almost a 0 to 100% scale, and it's used in many other industries and many other applications besides sugar, but that's by definition what Brix is. So a slightly more technical answer is the refractive index measurement is actually a measurement of the speed, or a ratio of speed of light in a vacuum versus the speed of light in the medium being measured. We have a whole paper on that if you want to know about it, put together by some physicists that are a lot smarter than me. We can help you out if you want to learn how this works. You can also go to Google and check that out. So here is what is commonly used in the industry. It's a handheld refractometer. Now this is going to be used just to take a spot check. It's not in line. It's a spot check of what's going on. You take a sample out of the process and you place it on the surface, and you can now hold it up to the light and read what's going on. What the concentration is in your process. But there's a few potential problems. We use refractometers for a couple of reasons. In line, a customer might want one because it's going to save costs because they have a more accurate process. It could be that they want a more consistent process, but it could also be a safety issue. If you were taking a sample of a very hot or acidic process, and you hold it up to the light with it dripping in your eye, what could possibly go wrong with that, right? So it could be a safety issue as well. But this just kind of shows you the shadow line, which we'll talk about in a little bit, about how you can take that measurement. And in this case, this sensor is measuring salinity. So it's actually measuring salt water or the salinity. You would use this, for instance, in biological applications, or in my case, I actually use one for measuring the salt concentration in my saltwater fish tank. Again, this is about a 1% device, and it really comes down to who's using it and how they use it. If they use it properly and consistently, you'll get consistent results, but you could have 4 or 5 operators using one of these and they get 4 or 5 different readings. So that's where the inline process refractometer comes in. It gives you a much more accurate, much more consistent, and very fast, instantaneous reading. So now we'll get into the overview of our refractometer. So we have what we call the core optics. The core optics, it's a light source, a very specific wavelength of light or color of light that shines from within the core optics, strikes the prism, and then it bounces around in that prism and comes back to a CCD or detector that looks at the shadow line that we saw on the previous slide here. It actually creates a shadow much like this one here, and we look at where that lands. That's what we call the critical angle. So some of the light from this light source gets refracted into the process, while some of the light gets reflected back. And that critical angle creates that shadow, and that's what we are measuring. So here's just sort of an overview of how that looks. One thing that's important to note is we're looking at the shadow line, the difference between the dark and the light areas. So if a bubble passes and it reflects or refracts the light slightly differently in that area of the bubble, it's going to show up as a little bright blip on the CCD, but it's not going to affect where that shadow line shows up. So you won't have any influence from that particle or bubble. Also, color does not affect the measurement at all. This is what we call the critical angle. That's where that shadow line lands on the image sensor and gives you that concentration measurement. All of these, all of our sensors are calibrated at the factory with NIST traceable oils that have a very specific optical property to them, and that correlates to whatever chemical scale you'll be using. So very accurate, highly accurate devices, and again, you can probably expect close to 0.1% of the concentration that you're measuring, and if that isn't what is happening in the real world, there can be things that bring it back and make it more accurate for you. Okay, I'm not sure if this is going to work, but we will see if a video plays here. So this is an animation of how it's actually working. As the concentration changes, you can see that shadow line moves. You can see the light reflected from a bubble. It shows up as that blip, but it doesn't affect the overall image and where that critical angle or that shadow line shows. Jim, were you able to see that animation at all?
Yes, it looked fine.
Great, great. Let's play that one more time so you can see it. This is an oversimplification, but you get a really good idea of how this works.
Michael, there's a question that came in regarding, you mentioned calibration. So Does this device ever need to be calibrated? You know, like say a pressure transmitter would, or what does that process look like?
Sure, that's a good question, and one that we get frequently. So at the factory, we calibrate it. It's typically a very linear device, but we calibrate it at 5 different points within that 0 to 100 bricks measurement scale. And when you put it into your process, generally speaking, unless any conditions with it change, like somebody hit it with a hammer or dropped it, there shouldn't be any changes in its calibration. It's a very robust, we'll get into the core. I don't think I actually get into the core optics, but it's a very stable potted thing. And think of it as a pair of binoculars. You really don't have to calibrate a pair of binoculars or an electronic camera. They're very stable inherently. Same thing here, it's potted in epoxy and nothing really changes. The only thing that could change is that prism, if it needs to be changed out or it gets scratched and damaged and it needs to be changed out because of that, you would go ahead and send it into our factory and we would do that calibration for you. But many of you will have a practice of verifying the instrumentation that you have. In this case, what I would do is potentially verify it with one or a few of these oils and do that maybe once a month until you get some history and some confidence in it, and then do it once a year. But generally speaking, these do not require any kind of calibration. Again, they're very stable. And I literally have customers that have had these in for 10 years and quite honestly forget about them because they work so well. The answer is we really don't need calibration unless something physically changes, and that usually doesn't happen unless the prism is changed out. So great question. So here are a couple of industries, well, actually a lot of industries that we are in. You can see the pulp and paper, food and beverage, and chemicals are some of our biggest. We're in semicon, where there's some very aggressive chemicals. We have sensors designed for that, where the only thing in contact with the process is Teflon and the sapphire prism. Metals and mining, life sciences, oil and gas, just a plethora of industries. The applications are vast as well. Mixing and blending is a big one. Dissolving or evaporating, cooking. So the list goes on and on. As far as the units of measure, some of you may know of some of these, but bricks is by far the biggest one that we use. The Oaksley is for those of you that are zymergists and make wine. That is a scale for making wine. How much sugar is in the must before you ferment? I think that's right. The must for winemaking. But there's basically a number of different scales that you can use. And with Vaisala, Vaisala purchased a company called K-Patents back 5 years ago or so. And K-Patents has been around for a long time. And we have built chemical curves that convert the refractive index, the optical measurement, and correlate that to a chemical concentration. And we have a number of different chemical concentrations as well for acids, caustics, various other chemicals. If bricks is not quite what you're doing, many scientists use refractive index and don't really care about the concentration, and they go to the CRC and compare it and maybe run it into their PLCs, that kind of thing. But if you need a very specific chemical concentration curve, we can do that for you. So we talked a little bit about the sensors and applications. This is our transmitter. This is the Indigo 520 transmitter. Very nice user interface. It powers up the sensor, gives you the nice display, graphical display allows you to look at diagnostics of the process and the sensor. Key to our sensors is keeping that prism clean. If it gets a coating and that coating keeps it from seeing the process, there could be some issues. So you want to keep that sensor clean, and a lot of ways to mitigate the problems associated with a dirty sensor is to increase the velocity or use CIP, for instance. That'll help clean it. Use velocity to keep it going fast past the sensor. Mount it in a 90-degree elbow so there's a change in direction right at the sensor. That helps keep it clean before it gets dirty. We also have steam and water injection to keep it clean. But the beauty of using the transmitter is it allows you to help determine how healthy the process sensor is, the inline process sensor is, and what that signal looks like. And here's just a screenshot showing some of the diagnostic screens. Yeah, it's a nice interface. It's not necessary, but it is very nice to use. Again, it powers up the sensor. It allows two sensors to be used at once. And because it's used with our other products, you can actually mix and match. So you can have one refractometer connected as well as a humidity and temperature sensor, for instance. So now you can monitor the room environment as well as what's going through your pipe. Here's just a number of the different sensors and technologies that can be connected. So we have dry cap, which is a humidity cap, basically looking at very low dew points. Carbo cap, looking at carbon dioxide in the air. Peroxide for hydrogen peroxide in the air for disinfecting a room, for instance. The humicap, that's one of the things that Vaisala does very, very well. The humidity, temperature, and even moisture in oil for the power industry, looking at moisture content in oil. You don't want moisture in oil for some of the power transformers, and we can actually monitor what is going on in that oil from the moisture standpoint. Barometric pressure transmitter, and of course at the top there the Polaris refractometer for liquid concentrations. All these sensors have one thing in common, and that is all the smarts are in the sensor. And when you connect it to the Indigo platform, it automatically recognizes it and now gives you the user interface, the screens, and so on that's associated for that measurement. So it's basically scalable and future-proof. If you buy the transmitter, you can connect any of these in any future device later on with just a simple firmware update. Again, some of the applications here, food and beverage, life science, and so on, we won't get too much into this. Again, we've already covered it. But here, one of my favorite applications, and one that we do a lot, is in food and beverages, is fruits, vegetables, and in this case, we're showing tomatoes, so ketchup and sauces and things like that. You're looking at the concentration of not only the sugars that are there, but it also measures vinegar concentration and so on. We can't necessarily discern sugar from vinegar, but if you add them, each additional addition causes a different refractive index, and now you can use it to control set points along the way to build up your recipe. So you can make soup or ketchup if you'd like.
Michael, I did have one question. The question was, can you clarify if you can take the output from the transmitter directly into a control system, or do you have to use the display transmitter?
Okay, so yes, in many applications, our customers like to have an HMI right in front of them. There are some applications where the customer doesn't want that. Either way, we can have connectivity to your PLC or your control system, either from the sensor directly, foregoing the transmitter altogether. You simply provide power to the sensor, and then you have your outputs either digitally or analog from the sensor. If you wish to have the HMI, you would purchase the sensor and the transmitter, the Indigo 520 transmitter. You power up the transmitter either with 120 volts, 24 volts, or even power over Ethernet. And now you have your outputs. If you go power over Ethernet, you only have the Ethernet connectivity with Modbus TCP/IP. But if you go the 24 volt route or the 120 volt route, you will have 4-to-20s, relays, and the digital communication platform through Ethernet connection.
Great. Another question that came in was, is the transmitter available with HART?
At this point, it is not. As far as I know, it is not. And I'm not sure that we're coming out with HART in the future, but duly noted.
Thank you. That's all the questions at the moment.
Okay, great. Again, some of the typical applications. Here's some more for food and beverage, so alcoholic beverages, looking at how much sugar is in it before fermentation, perhaps, or during fermentation to make sure it's complete, or maybe not even complete, but get to a certain point where you want to cut it off and have some remaining sugars, for instance. Juice and soft drinks, you want to maintain and have a consistent product. If you are adding water to a concentrated solution, a concentrated juice, the water is cheaper than the juice. You're going to save money if you introduce the right amount of water and not over introduce the juice components. Coffee and tea, to make sure that you have proper extraction. Dairy, boy, there's a number of different applications there. A lot of them are in concentrating and drying for making whey and protein shakes, dry protein. A lot of different applications in dairy. Again, fruits, vegetable processing, we mentioned some of that. Ingredients, we have a number of customers that are making food ingredients. They don't actually make any food products, but they make the additives that many of the big houses use to help flavor their products. Egg products, just a lot of different things there. Obviously, confectionery and sweets, that's where the sugary products are going to be using ours to maintain a very specific sweetness to them. We're found in, fondants and icing, frostings, cakes, fats and oils. That one you have to be a little bit careful of because you won't be able to see some of the fats and oils, but if it's homogenated and small globules of fat, we can measure that. If there's any applications out there, please let us know. We'll be sure to help you out and figure out if we can help you there. Meat production, prepared foods, and so on. Just a number of different applications in food and beverage. This is one of my favorite, brewing beer. We do help with brewing beer. This is just a schematic overview. You can see there's from the mash, the lauter tun, the boiling, fermentation, just a lot of different steps in brewing beer that many people wouldn't even think of, where you could use an inline refractometer to help with consistency and production. Whey protein, I mentioned that. As you're concentrating, you want to pull out a lot of that moisture, and doing that helps just before spray drying. Spray drying would be expensive, and if you can remove most of that moisture before you start spray drying, you do that by boiling and heating it up in a cooker, for instance, you will help remove some of that, so it helps in concentrating. We do a lot in spray drying. Here's a number of other applications again in whey protein. This one very specific for whey protein powder production. Again, we have literally hundreds of application notes that describe the application. If you go to our website, you can see all of these and download them. You can get more information regarding how our products help make a better product, how our refractometers help make a better, more consistent product for you. Hundreds of applications, application notes, giving you an overview of how it will help. Chemicals, boy, we can measure virtually any chemical because there is going to be a refractive index change in those chemicals. I guess the only thing you need to worry about is chemical compatibility at that point, and we have sensors that will work in almost any of these aggressive applications. Bulk and fine chemicals, whether you're taking a bulk chemical that's highly concentrated and you're putting it into a bottle and packaging it, and you need to bring it down to a lower strength, we can help you attain that concentration and make sure that you aren't putting in too much of the, let's say, water to cut the product, or having too much product go out and then costing you money. Again, consistency is one of the things that many customers are looking for, and my customers as well as your customers. You want to make sure that you have the same product and a consistent product. You don't want to have varying concentrations. So chloralkaline products, polymers, plastics, fertilizers, explosives, a lot of chemicals used in fertilizers, biochemicals, to just a number of different applications out there where an inline refractometer might be the only way to go. Again, I talked about conductivity, for instance. Conductivity can help you. It's sometimes a cheaper alternative, but it's not going to measure everything. You have to have, it needs to be conductive to work. So for instance, in the sugar industry, conductivity will not work. And potentially you could use a Coriolis to look at the density, but that is looking at the overall density. And it is looking at both the dissolved solids as well as the suspended solids. And in many cases, you want to only know the dissolved solids. Our sensor inline refractometer is immune to, again, the color, bubbles, any of the solids that are there. So you're looking at only what is dissolved. Chloroxy process, you can see a number of different applications here. The hydrochloric acid, your sulfuric acid, sodium hypochlorite, brine. It's used in the evaporators, all the way to the final product. So there's a lot going on with this slide, but it gives you an overview of where we are with chemicals. Again, sulfuric acid, many different steps in making sulfuric acid, all the way from the raw materials coming in, all the way to the storage tank, and then even after this, where you are diluting it, where you need it to be a lower strength. This is a little bit of an eye chart here for you, but you can see there's a lot of different applications for us. Polymerization, this is NBR, production of NBR by polymerization. Any different steps within it, and we can help you there as well. Okay, so that was just a very 30,000 foot high, very brief overview of our applications. This is a picture of our hygienic sensor. We use this in a lot of our processes where 3A approval is needed, food and beverage, pharmaceutical, and so on. It is again, factory calibrated 0 to 100% bricks, or 0 to 100 bricks is the typical scale. We do have some different materials available, Hastelloy C, titanium, exotic metals, so that even a CIP won't harm it. CIP, chemical cleaning. There's also steam cleaning, so we can handle the temperatures involved with it. This is a very robust, compact refractometer. We call it the hygienic because, well, it is hygienic, but it is also used in a lot of applications where hygienic isn't necessary, simply because it has the triclover or tri-clamp fitting for putting it into your process. It makes it very easy to remove from the process if you need to remove it to do a verification or change it out to another sensor because you're doing some PM or what have you. It's very easy to change it out. And if you want to pull it out to do some extensive cleaning or remove it because you just don't need it for a particular process, you can remove it, put a blank cap on it, and it's just very easy to put into and take out of the process. Again, 3A, E-hedge. So you have the various approvals for here in the United States as well as Europe. Does again have the digital and the analog outputs. Pretty much maintenance free as long as you keep that prism area clean. You just don't want any kind of a buildup. If there's any chance that you're going to build it up, please give us a call, talk to your salesperson at Lesman, and figure out what it is that we can do to help mitigate any of the coatings. But if there is a coating that comes over that sensor area, there could be some issues. But with the diagnostics and so on, there's what's called a quality factor that we display on our transmitter. That is sort of a trust coefficient, if you will. What does the signal look like? Is it trustworthy or not? It's not so much a number that you need to be worried about as a number itself, but if you see it starting to slip from a high number to a low number over time, that could mean that you're getting a coating and you need to pull the sensor for cleaning or do something else. But yeah, typically the upper left there is how we like to see it installed, where you simply weld a fitting onto your existing 2.5 inch or larger stainless steel pipe. Again, and we like it in the elbow. That helps mitigate any coatings. We also have small pipe, so your process connections can be 1/2 inch, 1 inch, 1.5 inch, 2 inch, and so on. All the way up to, boy, putting this in a 30-inch pipe if you want. The left shows it put in a elbow of 2.5 inch or larger. The right-hand side shows our flow cells. We even have some reduced inlet to help increase the velocity. In our case, velocity is your friend. Again, it helps keep the sensor clean. We typically like to see 3 to 5 feet per second or higher in applications where there tends to be any kind of a coating. You can put it into a straight line. Preferably, you want it going up. You want the flow going up, and I would recommend that for flow meters and pH sensors, conductivity sensors, everything. Because when the flow is going up in a closed pipe, you can always guarantee it's either a full pipe or an empty pipe. If it's going down, you will never know if it's a partially filled pipe or an empty pipe. It just helps maintain proper contact with the sensor, whatever technology it is. In this case, obviously the refractometer shown here. This is our sanitary long mount, long snout sensor. Gets it further into the process. It's very similar to the other one. It's just a longer snout from that tri-clamp fitting. This is called the AP sensor, very similar to the other one. You can see the applications for this, putting it into larger pipes, even going into the side of a tank. High temperature, again, CIP, SIP systems can be used here. Almost an eye chart, again, just showing you application checklist for hygienic processes. Again, refractive index sensitive to the dissolved materials only, is not affected by bubbles, color. Range, expected accuracy, again, typically 0.1%. We have very good repeatability. If somehow there's a mismatch between the lab and our reading, you have to choose a dog in the race. Which one are you going to trust? If for whatever reason you trust the lab more than our reading, we can change that. We can actually make it read what you need simply by doing an offset or even a field calibration. The bricks scale is very well defined. If ours is reading 22 bricks, 22.1 bricks, it's probably right, but it may not agree with the lab. And we can give it an offset and make it read what you'd like. So now you get a more consistent agreement with the lab. Pressures up to 580 psi or 40 bar. Yeah, so don't want to read the chart here, but you can read it yourself. So this is our flanged version. This is our GP. Again, very similar to the other sensors, except it's a ANSI class flange. And you can see this one here has our cleaning system. May not be real easy to see, but you'll see parallel to the snout of the sensor, there's a tube. That tube runs from the flange, and you connect process steam or process water. You may have steam running throughout your facility or hot water. You just simply, well, it may not be simple. You may have to use some high pressure things and valves and so on, but you simply connect your steam or water to this and control it. This is where the transmitter comes into play. You use the transmitter to control the duration, the frequency, and so on of that cleaning, and it actually cleans that sensor tip, and you can use that before you have a problem. So you would use it maybe every 10 minutes, and it prevents a buildup of any potential coating. Pulp and paper, as I mentioned, is a huge part of our business, and wood pulp obviously is huge. This, just a very quick overview, this is what we call our safe drive. We have these literally for 20 years. We've been using these in pulp and paper. Very high fiber content, is not going to cause any problems. We can measure high solids concentration up to 90%. It's a special prism in some cases. This here is the safe drive attached to a sensor. It allows you to insert it into the process and remove it, as the name suggests, very safely. Again, there's some very aggressive chemicals involved. There's high pressures, super high temperatures. This is a perfect example of why you'd want to have a inline refractometer versus taking samples, not only just because you want to control it better and have an instantaneous reading, but the safety involved with taking a sample is a very important consideration for pulp and paper. But this is a mechanism for pulling it out of the process while it's running. So it's basically a hot tap with a lot of safety engineered into it to keep the operators safe and not have either hot process or chemicals being sprayed onto the operator. So again, an overview of our product, the Indigo platform, along with our different sensors. Modular Indigo platform, we call it. Very flexible, interchangeable, scalable, future-proof. This is our 5th generation, the Polaris. Again, very robust design. It's built on the platform that's literally been around for decades, just updated into a nicer package with a lot more features that many of our customers are looking for today. The Ethernet connection that we have is very safe. Password protection and so on, just brought into the new century here. Again, drift-free measurement, wide offering with various sensors and installation methods to the process. We do some engineered to order items as well. If you need something special, please feel free to reach out to us. We can generally accommodate you. It may take a little bit to get an answer, but we can certainly look into it and see if we can help. We have a global presence, local customer service. Obviously, Lesman can help you out. I can help you out. I'm local. I'm out of the Milwaukee area. Fast delivery. If you're looking for something fast, we can ship usually within 3 days, at least for a quantity of 1 or 2. So that is basically the end of my presentation. I'll turn it over to Jim and any questions you may have. I think we're finishing up a little bit earlier.
Actually, I think we're right on the money, Michael. Thank you. The only other comment I wanted to make was I thought that the transmitter option is very nice, and it really gives you that additional diagnostics right on that probe if you would actually get buildup on it, and really seems to be a nice feature where you can kind of know in advance of having a problem, right? So to me, that seems like a real, if we have any potential for buildup, to me, that seems like a real nice feature to eliminate worrying about stuff that could happen. And then the other takeaway for me was, that delivery is still in the post-pandemic era. Whether you're looking for a refractometer or even if you're looking for a Coriolis meter to measure density or what have you, this product is something that you can get really quickly. And if you've been using a different technology to get the same result, this could be a potential benefit for those who need something quickly. So that was kind of my just a few takeaways from the presentation. So other than that, I don't have any additional questions other than the ones that were asked prior. So with that being said, I wanted to thank Michael for his time this morning and his presentation, and I want to thank everybody for joining us. And if you have any questions, you can follow up with myself, Jim H. at lesman.com, or you can certainly reach out to Michael. His phone number is 262-339-5082, or his email is michael.kohlmann with 2 N's at vaisala.com. So with that being said, again, I want to thank everybody and enjoy this Thursday. And again, reach out to us if you have any questions. Thank you.